Hello, in this video I'm going to talk about factorizing in algebra. We've already covered expansion, at least the very basics of algebraic expansion. So now it's time to cover factorizing. And basically factorizing is the opposite of expansion. Okay, the key idea when it comes to factorizing in algebra is you want to look for the highest number that will divide into all terms. Okay, we want to find, or in other words, we want to find what to multiply together to get an expression. So when it comes to expansion, if we use a very general example of a times b plus c, which you will have seen in previous videos for sure, okay, we know that this is going to equal a b plus a c, right? A times b plus a times c. Well, factorizing is the reverse process, basically. We want to understand how we got this final expression. Okay, so you're going to want to look, if the key intuition is to look for the highest number that will divide into all terms. In other words, you could say that what we're looking for is the greatest common factor. Okay, so in this example, if we were to factor this out, well, we have AB and an AC. The common factor here is A, right? We have an A here and an A here. So we can factor that A out. And so what we end up with is, well, where we started before we expanded, which would be A times B plus C, right? We've just factored this A back out. Here, we distributed the A in, right, which gave us this, and now we want to factor, right? So that's expansion. Okay, and this is factorizing or factoring. If you're in North America, it means the same thing. Factoring. So here we've just factored this a out. We've done the reverse. We've pulled the a out, the greatest common factor out. Right. So we can cover a few examples to start. Say, for instance, we have something. Say we have 4x plus 8. Okay, well the greatest common factor here, I mean 2, it's divisible by 2, but that wouldn't be the greatest common factor. The greatest common factor would be 4, right? Because 4 goes into 4x and 4 goes into 8. So, in other words, maybe it's a better way to write this. Well, so what this would equal then would be 4x plus 2. Okay, and how did I get that? Well, you're dividing both of these by 4, right? 4x divided by 4 is going to be 1. X is just going to be x, right? There's just a 1 there, x. And 8 divided by 4 is 2. Okay, so in this case, the greatest common factor is 4, so we're just going to pull that out, and then we're going to have that multiply in the new brackets, so x plus 2 in this case. And you can check your answer by just expanding, by following the basic rules of expansion, the distributive property, right? If we were to distribute this 4 into these brackets, 4 times x is just 4x, 4 times 2 is just 8, so it's just going to be plus 8, and we get what we started with. But if I confused you a little bit, let's just do another example. Say we have something like 20x plus 5. Okay, well, what's this going to equal? Well, the greatest common factor here is going to be 5, right? Because, well, 5 goes into 5, obviously. 5 goes into 20 4 times, right? So we can factor out a 5. So we pull out the 5. And then what do we multiply 5 by to get 20? Well, it's 4. So it's going to be 4x and then plus 1, right? Because 5 times 1 is 5. So what we're doing is dividing. We've identified the greatest common factor, which in this case is 5. Then you're dividing your terms. Like we said, the key intuition here is to look for the highest number that will divide to all terms. Okay, so that's what we've done. We've identified our greatest common factor, which is 5, and we've just basically divided this by 5. We've pulled 5 out, which leaves us with 5 times 4x plus 1. Okay, and again, you can prove you can prove this, or ensure that you're correct by just distributing this 5 back in, and you're going to end up with 20x plus 5. Okay, that's basic. That's all that that factorizing is, in essence. That's its basic idea, its basic intuition. So we can do another one, say something that looks a little bit more complicated. Let's say we have x squared minus 7x. Okay, well, here the greatest common factor is x, right? We have an x term here, x squared. We have x here. Okay, I mean, there's just a 1 here implicitly, but we don't need to write that. And so we've identified our greatest common factor, which is x. So we're just going to pull an x out, right? So we pull an x out. What's that leave us with? If we take an x away from all this, well, it's going to be x minus 7, right? And again, if we were to distribute this x back in, we would end up with this original expression, x squared minus 7x, right? Because x times x is x squared. X times minus 7 is minus 7x. Can do another one thing. Let's say, yeah, let's trying to think of something a little bit different. Let's say we have, okay, let's say, I'll write it up here. Let's say we have 9x squared y plus 15x y squared. Okay, well, again, the first thing we have to do is try to identify our greatest common factors. Okay, well, we know that 3 goes into 9, right? 3 times 3 is 9, so 3, and we know 3 goes into 15, right? 3 times 5 is 15. So 3 is going to be one of our greatest common factors. But what about these x terms? X, y, x squared, y, and then here we have this plus 15x y squared. Well, they both have an x, y, don't they? So that's another common factor that we can pull out. So in this case, we know 3 goes into 9 3 times, and that's going to be, yeah, and 3 times 5 is 15, right? So we're going to pull out, 3 is our greatest common factor, we're going to pull out a 3, and then we're going to pull out an x, y. And what's that leave us with? Well, 3 times 3 is 9, as we said, so it's going to be 3. Now remember, this is x squared, so it's going to be 3x. We've just pulled out 1x from this, right? So we're still left with an x. So it's going to be 3x, and then here we have 2 y's. We've only pulled out 1 y, right? So that's going to be 3x plus 5y. So if you think about it now in reverse, since we've just factorized, if you were to expand this, well, 3xy times 3x, that's going to be 3x squared y, or 9x squared y, sorry, right? 9x squared y. If you were to distribute this 3xy into this 5y, well, what's that going to give us? That's going to be 15 y squared with an x, right? So 15xy squared. So that's how we know that we've successfully factorized. We can do one last example, say, one last example before we move on. Say we've got 3x squared minus 9x y. I was going to add something else, but I'll leave that here, okay? So how do we, well, we know that already. We can see that very quickly that 3 is a greatest common factor, right? 3 goes into 3, obviously, and 3 goes into 9, right? And we have 2 x terms. We've got an x squared term, and we've got an x term here. So we know we can factor out an x. We're going to factor out a 3, okay? So actually, I'll get rid of that. So what this will equal would be 3x, right? Because we're factoring out an x, and we're factoring out a 3. So 3x, and that's going to leave us with x minus 3y, right? Because again, if we think of it in reverse now, if factorizing is the opposite of expansion, well, if we expand this, right? 3x times x, that's 3x squared. 3x times minus 3y, that's going to be minus 9xy, right? 3 times 3 is 9, x, y, right? So x times y. So there you go.